Welcome to Craftsman. My name is Sascha Feider and I'll be your instructor as we enter the realm of precision modeling in Blender. Not just as an exercise, but with real-world application in mind. In this course, we'll be working through designing and planning a custom built-in unit. And we'll approach it as if it were a real client project, because that's what it was. This built-in was entirely designed and planned in Blender. And all measurements, details and production information were taken directly from the Blender file. And throughout the lessons, I'll mix in a bit of retrospective on how the actual project played out, what was discussed, and why certain decisions were made. So you'll gain not just the technical skills, but also the practical context that makes it stick. Now, a bit about my background. I've been in the carpentry and cabinet industry since late 2005 in various capacities. And when I opened my own company in 2020, I wanted to have a better way to visualize my projects for clients other than just simple line drawings. And Blender became my tool of choice. Even back when I didn't know much about proper shading and lighting, and the presentation clearly shows it, I quickly realized just how powerful and accurate Blender actually can be. And soon after, I moved my entire planning and designing process to Blender, and these days I rarely ever touch CAD anymore. And when I say we're bringing the real world into this course, I mean it. We'll take time in my workshop to look at real-life materials and discuss practical considerations, and then return to Blender and learn how to implement and recreate those materials and conditions digitally. Because here's something I truly believe. Knowing how something is built in the real world helps us recreate it more accurately in 3D. And that's what this course is about. Now, before we jump in, a quick note on recommended requirements. I'll be using Blender 4.2 LTS, but in all honesty, the only major change to this entire workflow since I started doing it in Blender 2.9 has been the addition of the snap base point in 4.0, aside from the usual minor UI tweaks between versions. And you should also have a basic understanding of Blender itself, modeling, texturing, and lighting. So ideally, you've done the Blender basics and some of the fundamentals, which are, of course, available here on CG Cookie. But enough prelude, let's get started, see if Blender can be precise, and create ourselves a built-in. Blender and precision modeling. Well, there's a topic that can spark quite the discussion. At times an even very contentious one. Believe me, I've been there. You'll often find those who are totally convinced that it's absolutely impossible, going up against those who say it is. But why is that discussion held sometimes in such extreme ways? And is it really possible to be precise in Blender? Well, the answer to the first question is welcome to the internet. What can I say? The answer to the second question is not a simple yes or no. First, we need to understand the fundamental differences between a program like Blender and a CAD program. Blender is a polygon modeler, meaning it relies on vertices and edges and faces to create geometry, which is great for an artistic workflow. CAD, on the other hand, is a parametric modeler, meaning it creates geometry using math with dimensions and constraints. And that's why it's used in engineering and manufacturing. Even the way these programs represent geometry is based on two fundamentally different systems. Blender and other poly modelers use polygons and often subdivided surfaces to represent the geometry. CAD programs rely on NURBS or BREP, which is boundary representation. And this allows for mathematically perfect curvatures, and booleans without overlapping faces and all the other mess that we're used to seeing in Blender. And that's where the key issue lies. Because Blender relies on vertices and edges, there will always be a tolerance when taking dimensions. For example, on a circle, there will always be a slight difference between measuring from vertex to vertex and edge to edge. The way we can make those differences smaller is by subdividing our meshes more and more. Those differences, however, don't exist in a CAD program, which is why some say CAD programs are the only ones who can be precise. So, is Blender really that inaccurate that we cannot call it precise? Well, that depends on the use case. In most use cases, especially in visualizations, architecture, furniture design, or carpentry, the level of inaccuracy in Blender is so small, it's pretty much irrelevant. You'd have to be working on a scale that requires sub-millimeter tolerances for it to really become a problem. Think of precision machine parts. That's where CAD would be a preferred program. Recently I had somebody tell me that they tested some of my tips on a 1/10 of a millimeter scale, and apparently it was still precise enough. So I think precision is definitely possible. By default though, Blender doesn't have the perfect setup for it. So let's change that and activate a few tools that we'll need along the way. Let's first change the units. In cabinet making, we work with millimeters. So let's pop over to our Scene Properties tab on the right side here. And there we'll find the units. Now by default, Blender is set to metric and meters. And we're going to leave it on metric, but we're going to switch it over to millimeters. And with that, we already have our precision set to the scale that we require. Next, let's activate a few extensions that will help us during our modeling process. So under Edit, go to Preferences and make sure that under System you have Allow Online Access toggled so we can download extensions. And then under the Get Extensions tab, we can look for what we need. So let's start with measurements. We need to be able to extract measurements from our model. And for that, we're going to use the Measure It add-on. So search for that, and then on the right side here, you should have this install button if you haven't installed it already. And then just to make sure, you can go under add-ons once you've installed it and look for it there and make sure that it is actually toggled on. Next, I want to add a couple of tools that will help us during the modeling process. The first one is the bool tool. So we can see it right here, but you can always search for it too, the bool tool. And again, where it says update on my end, you can just install it there. The next one is the loop tools. And then we also want the F2, which you can see right here. Another tool I really like, you can see right here, the copy attributes menu, and we'll use that once or twice in the course at least. And then of course everybody's favorite, which you won't find under the extensions, but in the add-ons tab, which is the Node Wrangler. So if you search for that, make sure it has a check mark. Now there are a couple of other extensions that can help with precision modeling, like the precision drawing tools, for example, but we won't be using those in this course. So that takes care of all our extensions and add-ons that we'll need. But there is one more thing I want to be able to access on the fly. So if I open up my N panel here, under View, I find my Measure It tools down here. And with those, I can extract dimensions from my models based on segments. So if I go in here and select two vertices, I can show and segment, and there I have my dimension, and I can then set the precision, the dimensions, etc. It's a great tool and we'll use that for sure. However, if I get rid of this, there's another way to quickly glance at the dimensions of our model while we're modeling and in edit mode. And that's the edge length overlay. And we can find that up here under the mesh edit overlays. Under measurements, we'll see a bunch of them. And one of them is the edge length overlay, and that is one I use frequently. And with that, when I toggle that on, we can now see the dimension of this edge here on the fly. It's a tool I use frequently, and I use it so frequently, in fact, that I don't want to go through this menu here all the time and toggle it on and off. Instead, I'm going to right click on it and click on Add to Quick Favorites. And now whenever I'm in edit mode, I can simply press Q and toggle it on and off on the fly. So I recommend you do that too, because that is something I will use frequently throughout the whole course. And with that, we're set and ready to make the site assessment next. At the beginning of every project, I like to do a first basic site assessment before I even talk to the client about details. And that way I can already steer the following conversation in the right direction and point out possible problem areas when they tell me what they want. So let's open up the provided starter file from the course files. And before we do anything with it, I suggest to save it under a different name so we have the original intact for the coming modeling phase. So I'm going to go under File, Save As, and I'm going to save it here. And I'm just going to call it Built-in Planning. Save As. And now we can do with that file whatever we want without losing the original. And now we can have a look at it. And I've also provided a render of the empty room so you can look at it in color, which is always important for a first impression too. Alternatively, of course, you could go up here to the material preview, and this is what you would find. Okay, so this is the site we'll be working with, and it's modeled after the actual site, wonkiness included, and we'll get to that. However, I made a few changes to it because the original room was huge, covering the whole length of the house. So what I did is bring this wall with the sliding glass door a lot closer. And then here on the other side, I added a wall and called it the divider wall. On the original site, that's where the kitchen is. In a dark stained wood with modern shaker style fronts, which will come into play when we design our built-in. But I didn't want to model a whole kitchen and blow up the size of the course files too much. So I opted to put a wall here instead. None of that changes the core of the site at all though. All right, so this is the area where the client wants a built-in. And what we have to do now at our first site assessment is look for any possible physical constraints and problem areas. Now, our main constraint, of course, is that it's completely surrounded by the two walls, the ceiling, and the floor, hence the name built-in. That means that when we plan it, we need to consider giving us the ability to adjust finishing trim panels to our walls to fit it in. Now, the other reason to do that is that, unlike in 3D software, in real life, there is no such thing as a perfectly straight or plumb wall or 90-degree angle. Depending on how the house is built, we have to factor in more or less bumps and waves in the walls. If the house is stick framed, for example, usually by the time the drywallers had their go at it and it's all mudded up, instead of a straight wall, you have what we in my region refer to as the sea to sky highway. Now, if you're not familiar with that, picture any windy mountain road. Now, this may, of course, be exaggerated, but nonetheless, we have to account for it when we plan our built-in. And we'll know more about how bad it actually is once we start taking our measurements. Just let me assure you that it can get pretty bad. I recently built some corner shelves. And despite the house being brand new and had IFC walls, the corners were up to 5 millimeters out of square on a length of only 430 millimeters, which is absolutely bananas. But anyway, moving on. We can also see here that the depth of this alcove will limit the depth of our cabinets to less than regular kitchen counter depth. And then we have the baseboards here, which appear to be higher than the regular clearance of a standard base cabinet, which would be 100 millimeters. So we'll definitely have to take a look at that when we take our measurements. And lastly, we need to account for any obstacles, like utilities, for example, that we have to factor in during the planning phase. Luckily, in this case, there is only this one electrical outlet, which is nothing that we need to worry about during the modeling. It's merely something that after the install needs to be accessible. So there has to be a cutout in the back of the cabinet, which means when we plan it, we want to avoid having the side of a base cabinet right in that location. And of course, on other sides, there might be more in the way, like water pipes and vents, if you go in the kitchen or a bathroom, for example. But again, here we're lucky, it's only one outlet. And now that we have our first site assessment, it's now time to talk to the client about their needs for the project, and then we'll make a plan for it in the next lesson. The single most important aspect of our built-in is of course what the client's wishes and needs for the project are. That's the main guide to our whole design. So let's assume now that we had a detailed conversation with them and now know what they are. So for the style, they want to go with a modern farmhouse style. And because they have the kitchen right beside it, which already has shaker style front, we want to go with shaker style fronts for the built-in too. However, they don't want it as dark as the kitchen is, because the kitchen is already dark and the floor is dark. So they want to have something bright colored, ideally as white as possible, but still wood. So after a little bit of back and forth and tossing ideas, we opted for whitewashed oak. Now the whole built-in is going to be split into two parts, base cabinets and hangers, rather than a continuous piece from bottom all the way up to the top. The base is supposed to have large and deep drawers to store lots of stuff like plates, etc. And it's also supposed to have two pullouts for bottles where they can store their spirits and wines and stuff. And then they want a live edge bar top on top of that base. Now for the hangers, they want to store and display a bunch of antique and inherited glasses and fine china, vases and goblets and stuff like that. So they want to have glass doors. However, they don't want to have just one big glass pane. They want to have it a little bit broken up, and going along with the farmhouse style, we opted for muntins. And also to break up the big wall of hangers, we decided to have the outer hangers a little bit shallower than the middle ones, just to loosen it up a little. And then to finish it up, they want to have a nice profile on the top to convey the farmhouse style. And they also want to have some lights inside the hangers, behind the glass doors, and under the hangers. So now we know what the client wants. Now, as a preparation for the planning stage, we need to talk a bit about a few design principles that you have to keep in mind and should be aware of whenever you plan cabinetry and furniture, be it for production or just simply for Acquis. And I'll demonstrate some of them on the actual product. So for starters, the standard height for base cabinets, including countertop, is 910 millimeters from floor to top of the countertop. Now those are kitchen dimensions. For vanities, it's usually a little lower. Vanities are usually around the 810 millimeters top of countertop. And there is also a standard distance between the top of the countertop and the underside of hanger cabinets, which usually starts at about 450 millimeters and can range up to 550 millimeters. Again, those are taken from standard kitchen dimensions. Now, the thing to note here is that these ranges can vary a little bit, not too much, but a little bit, depending on regional building codes. So if you're doing something for production or for commercial clients, you might want to look up regional building codes and confirm those ranges. Now, in regards to hanger cabinets, we got to keep in mind the size and weight of those because they're going to be hung on the wall. We don't want to make them too big, especially regarding the door height and sizes. For example, you don't want to have an 800 millimeter door so that you always have to take a step back whenever you want to open it. And also here we have glass doors, for example. Glass is heavy. So it's okay to split up hanger cabinets if you have a certain height. Another good practice when planning cabinetry is to have some symmetry in it, lining up vertical and horizontal lines to convey the design clearly and have some clear structure in it. It gives it a way more professional look that way. Now, doors should always be able to be opened at the very least to 90 degrees. That means for us, when we plan, we have to stay away from walls by at least the projection height of whatever knob or pull we plan to use. Otherwise, we'll run into problems. If we look at a cabinet here, and I go into top view and we just open this door here, eventually the pull on here will bump into the walls. And we will not be able to open that door a full 90 degrees. So whatever the projection height of your pull is or knob, you want to stay away from the wall with that cabinet by at least that. So you can open the door 90 degrees or even more. It also depends on what kind of hinge you use. A lot of the European style hinges range from anywhere between 92 and 110 degrees. There are different ones also that can open up to 170 degrees, but those are the standard hinges. So you just want to make sure that you can open the door at least 90 degrees. And the same goes for inside corners if you have two cabinets running into each other. In those positions, I usually just go for plain 50 millimeters in both directions, and that way I avoid something like this. Now, of course, if we go away from the wall with a cabinet, that leaves a gap, and those we fill with trim pieces. And if we have visible cabinet body sides, then we use a panel, and those should all be made ideally from the same material as the front. And that way you have continuous material in all the visible areas. Now, depending on the situation, there are, of course, more things that we need to consider, but that depends on the situation, and there's just too many things to list them all. But especially in kitchens, regarding heat, there's important things that we need to keep in mind, especially around combustibles. We need a lot more clearances around those. For example, here we have a stovetop that is lower than the surrounding countertop, which is fine in this case because it's an electrical one. Actually, I think that was an induction. But if this was a gas stovetop, we wouldn't be able to place it this way because around gas stovetops, we need a lot more clearance to combustible materials. And again, that is something you have to look up in regional building codes because those two can vary a little bit. So now with all that knowledge in mind, let's sketch out what we want to build. So I'm in my room here. I'm just going to go a little closer. And normally I would do that with a pencil on paper, but I'm just going to use the annotation tool to draw up a couple of lines here. So we would have a base cabinet here at about this height. Let me just make this red so we can see it a little better. So this would be about where the base cabinet is. And then our hangers would start just about here somewhere. And would end somewhere there. And then we would have the profile on top. So we got to keep in mind what the client wants here. They want 2 bottle pulls and drawers along the base. And to keep a little bit of symmetry, we're going to break it up a little. So we don't have a bunch of drawers next to each other and then 2 bottle pulls on one side. So what we do instead, we're going to use one big drawer cabinet in the middle. Now this isn't to scale. This is just to give you an idea of what we're going to do. And then we're going to surround that one with the 2 bottle pulls, which are a bit narrower. And how narrow they actually will be depends on what the client wants to store there. In this case, I just measured the average stuff they had and then just doubled it up. And that's the width of those bottle pulls. And then we have another drawer cabinet beside each of them. And then we have our trim panel here to the side. Something like that. And then the hanger cabinets, to have vertical lines going all the way through, we're just gonna have one cabinet on each side, the shallower ones, that line up perfectly with the cabinet underneath. So the trim panel will be ideally the same. And the same goes for this side. Right over here. And then the middle one, we're just going to split that in half and have 2 hanger cabinets here. Should be roughly about half. And that way we have at least symmetry here in these lines and there. Now I can already tell you that this is a very high room. It's got a very high ceiling, so the hanger cabinets will be split in 2. We opted to go with a bigger hanger cabinet on the bottom and then have smaller ones over top of it to store stuff that they don't need all that much. So we're gonna have one line here all the way through, even though the outsides will be set back a little. And the trim panel goes all the way through from top to bottom. So this is the rough plan. What does that mean for us now when we have to take the measurements? Well, as I said earlier, we have to keep in mind that walls are never perfectly straight. There might be bumps in there, they might be out of plumb. So we want to take at least 2 measurements along the height. So on the base cabinets, we want to take at least the length from here to here and the same along the top. And the same on the back side. Again, 90 degrees angles are not all too common. So we want to take those measurements on the front and the back. And then if we see it's really, really crazy, then eventually we have to take one in the middle too. But in that case, there would be other problems in the whole building if it was that extreme. That's why we plan those trim panels with a little bit of width. And then for the hanger cabinets, we'll do the same thing. We go on the bottom, front and back, and on the top, front and back. And because these are fairly high, I would also opt to make one in the middle. And then for the height, we're going to do practically the same thing, even though we have room to play with because they're not completely connected, but still, we need to know how high the actual ceiling is. So we're going to take a measurement here and in the back. And same on the other side. It's always better to take more measurements rather than less. That way you can avoid problems from the get-go. And then we're also going to take the same thing in the middle, because usually ceilings cave a little. So those are the measurements that we need to take. And then, as I mentioned in the first site assessment already, we also want to check the height of the baseboards to see if we get any problems with those. And then we should also make sure where this is, to make sure we don't have the side of a cabinet right in that position. Although with the size of the cabinets that we're planning here, I can already see that is not going to be an issue. So now that we have an idea what we want to build, it's time to take our measurements. So I'm going to go and open my N panel with N. And then under View, I see my Measure It tool down here. So I'm going to collapse this, open my measurement tool and click on Show. And under Configuration, I'm just going to go for a bright green color so I actually see what's happening. That light blue usually disappears on this gray background here. So then I'm going to select my wall and I'm going to go into Local View with /. Tab into Edit Mode. And you can already see a bunch of lines and vertices here. And these are in the position where we need to take our measurements. I made them there for two reasons. A, to make it easier for you. And B, to make the walls as wonky as they were on the actual site. So let's start taking measurements. Let's take the depth first. And then we'll see how bad it really is. So let's select these two vertices. And then we're just going to click on Segment. And then we get 0.52 meters. So we can adjust our precision here under units. We can switch over to millimeters. And then the precision here, we can determine how many decimals we need. When we measure stuff like this, we only need to go to the full millimeter. That's precise enough for our measurements here. So I'm just going to bring the precision down to 0. And then it's up to you if you want to hide the measurements unit or not. Personally, I hide it because I know I'm always in millimeters. So we know there's 515. And then we just go along and do the same thing in all these points. And you can already see we have 5 millimeters from top to bottom. Told you, can be bad. Wait till you see the other side. So let's start here. That's the same. Oh, we're getting less. Oh, even less. What is going on here? And this is what I'm talking about. So you grow in depth on the left side, the higher you go, and you shrink in depth the higher you go on the right side. I don't know what to tell you. Putting something in here that would be flush with both walls would be a nightmare. But that's why we take so many measurements. So let's do the length next. So let's make a segment here and on the back. And then we go along all these and do the same thing. All the segments that we've taken before, we take the length too. And again, we can already see that we have a bump somewhere in the middle here. It's 3014 in the middle, where it's 3012 on the bottom and on the top. So somewhere on the front here, the back seems to be fine. Somewhere on the front, the walls are bowed out. And again, that's where these trim panels come in, and that way we can score them and fit them in. And if this gets too busy for you, you can always hide these. So you can just click and drag your mouse over all these eyeball buttons here and just disable what you don't want to see. And that makes it easier to just look at the measurements that you actually want to see at any given time. So let's take the height, make a segment there, and on the back, same on the other side. And same thing again, there is 3 millimeters in there already. And now wait for the middle. Make a segment there, and it's even less. Now to get a segment from this point, we don't have a vertex down here. But what we can do is we can select the one on the back side here and then just measure along the Z-axis. And you can see on the front, it's even less. So the ceiling is definitely caving in. And that's actually quite common. So what I'm going to do here is I'm going to change the color here to a yellow. And I'm just going to click and drag that color onto all the vertical measurements. And that way I can see better which is which. So now we know how wonky it actually is. It's not too crazy, but there's definitely some stuff in there that we need to be aware of. So let's go out of local view, out of edit mode. And if I want to measure something else now, but I don't want to look at these measurements all the time, I can click on the little ghost icon here. And that way, whenever I select a different object or deselect everything, those measurements disappear. And as soon as I select that wall again, I can look at my measurements. So that keeps the viewport a little bit cleaner. So let's have a look at the baseboards, because I suspected at the first site assessment that these are higher than 100 millimeters. So I'm just going to tap into edit mode here and make a segment on the corner. And I was right. They are 114 millimeter. That means with the standard clearance under our base cabinets of 100 millimeters, we would run into a problem on the back here where the bottom of the cabinet bumps into the baseboards and we would not be able to push the cabinets all the way to the wall. Now in this case, because everything's going to be closed in and none of this will ever be visible again, I talked to the client and we agreed that we just take the baseboard out in the back. And that way we eliminate the problem. And on the sides, because we have the trim panels, we can just make a notch around the baseboards and that way we won't have an issue there and the kick can be fit in between. Now one final check here for our electrical outlet here. The downside of the measure it tool is that we cannot measure between two different objects. What we can do though is we're just gonna go on the wall and make a couple loop cuts. They don't have to be super precise. We can just eyeball them. I'm just gonna go to the outside here and make a loop on the top. And then I can take that vertex, make a segment there, and then grab this vertex, make a segment there. And that way I know that I need to have at least this much clearance from the right side to not have a cabinet side right there. So I can make my cutout to make that accessible. And then it can be behind drawers, that's not a problem. You can always take the drawer out and then access that electrical outlet. And now that we have all these measurements, we can take them to our sketch, or if we had something on paper, and refine everything. And for this project, I've made two line drawings for you, one from the front and one from the top. And those give you all the measurements that you need to know to follow along with this project. And you can always refer back to them and you'll find those in the course files. And if the need ever arises that we need to take additional measurements, then we can always refer back to this file and do whatever we want and need with it without interfering with our modeling file. And that's why we've saved this one as a separate one. So we have all our measurements. We have a plan and you have drawings in hand. Let's get ready for the modeling phase.